All right, in this video, we will be looking at the first two transformations, which are vertical and horizontal shifts. So that's your up, down, and your right, left movement. And these are things that you saw with parabolas in grade 10. So your right, left movement, the horizontal shift, is the value inside of your bracket with the X. And then your up, down movement or your vertical shifting is the number outside. Notice for shifting, both numbers are attached through addition or subtraction. So for your D value, which is your right-left movement, when D is greater than 0, then your bracket is actually going to look like X subtract your positive number. So it is X subtract a number. So when you see subtraction in the bracket, it actually means you're shifting to the right, however many units. When D is less than 0, what you end up having in your bracket is X subtract a negative number, and we know that two negatives make a positive. So that's actually X plus a number. That's how you would see it. So when you see addition in your bracket, you're actually moving to the left. And these are things you saw with parabolas in grade 10 as well. Inside the bracket, it was kind of like the opposite of logic. Then your vertical shifting or your up down is the value outside of the brackets that's being added on. So when your C value is greater than 0, you're shifting up, and when it's less than 0, you are shifting down. Now the actual letters D and C, it doesn't matter. It can be any letter. What I really want you to pay attention to is that the right-left movement is inside the bracket, and remember to think of the opposite sign, and your up down is outside the bracket. And again, both transformations are attached through addition or subtraction. All right, for the first set of examples, we are going to state the transformations, and then we're going to write those transformations using the specified base function. So for A, I have the parent function for the parabola, x squared, and the transformations that are being applied are f at x minus 4 plus 3. So let's start off by writing the equation, and I'm just going to label my new transformed function as g of x, but you can use any letter you want. So thinking of function notation, we know that whatever is inside the bracket will replace x. So in my parabola, I have x in front of the exponent, so I'm just going to do a swap here. So I'm going to write g of x, and then instead of x, I'll write x minus 4 all squared, and then that plus 3 will go outside the brackets. So the horizontal replaces the x, and the vertical is always outside of your function. So that being said, if I look inside my bracket, I have x minus 4. So because it says subtraction, I'm actually going to the right. So shift right 4 units. And the 3 outside the brackets is the up down. So I am shifting up 3 units. And this is the correct communication I want. The word shifting, the direction, and then make sure you state the units, not just the number. Okay, let's go to the next one. For the next one, our parent function is the square root of x, and we are doing f at x plus 7. So x plus 7 is inside the bracket, so I'm going to replace x with x plus 7, so that I have the square root of x plus 7. And because that plus 7 is inside the function, it means it is horizontal. So I am shifting to the left 7 units. Okay, remember that opposite direction. All right, let's try the next two. So I have my sine function, and we are doing f at x plus 90 and then plus 5. So I'm going to replace x with x plus 90, and the plus 5 will go outside the brackets. So why don't you pause the video here, try to set up your equation and state the transformations, and then come back to check your work. Okay, So for your transformed equation, hopefully you have sine of x plus 90 degrees and the plus 5 outside the function. So that means we are shifting to the left 90 degrees. And here you don't have to write 90 units because degrees are our units. And then we are shifting up 5 units. Okay, and then let's try the last one. We have our exponential function, 2 to the power of x, and we are doing f at x minus 4. So because I don't have anything inside this bracket, my transformed equation will stay as 2 to the power of x, and this subtract 4 will go outside the function to show that it is vertical. So the only transformation we have here is shift down 4 units. Okay, so that is how we interpret our transformations, write the equation, and how to communicate properly. Now let's move on to actually graphing our base functions and moving them around. All right, so for our first function, we have the square root function. So I'm just going to start off by plotting the base function, and then I'll deal with the transformations after. And with the square root, I know that I'm starting at 0, 0. I'm going to have 1, 1. Then I'm going to jump to 4 because the square root of 4 is 2. So that gives me the coordinate 4, 2. And then 9, 3. So you have to be efficient at plotting these points. And then I am going to label this as f at x because f at x is the base function. Now I'm actually going to look at my transformations. I am applying f at x minus 1 minus 5. And again, I'm going to write g of x for the transformed function. X minus 1 is inside the bracket, so that's what will go under my square root. And then minus 5 will go outside. I am going to list my transformations just from my knowledge, even though the question doesn't ask for it. But we are shifting to the right 1 unit. And we are shifting down 5 units. Now, with the shifting, if you want to do it all at once, that is fine. If you want to do it one step at a time, so shift the whole square root to the right 1 first, and then shift it all down 5, that's fine as well. For this first example, I will do it in 2 steps, but usually for me, the shifting stuff, I will do it all in 1 step because all at once, I can move everything to the right and down 5 units. Okay, so I'm going to start with the shifting right 1 unit first. So I'm going to take all of these key points and I'm just going to shimmy them over 1 to the right. So the point that was at 0, 0 is now at 1, 0. The point that was at 1, 1 is now at 2, 1. 5, 2, and 10, 3. And then I'm going to connect, and I do have to label this new graph. And this new graph is f at x minus 1. That's all I've done to it. I've only moved it to the right 1, so I can't write the rest of it. Now I'm going to take this blue square root, and I'm going to move all of those key points that I plotted down 5. So I'm going to take the point that's at 1, 0, and I'm going to move it down 5. So I end up at 1, negative 5. Then I'll do the same to the rest, so that I have a point at 2, negative 4, 5, negative 3, and 10, negative 2. And then I will connect my dots, and I can either label this as f at x minus 1 minus 5, or because I already stated that I am graphing g of x, I can also label this square root as g of x. And there we go. This is our final transformed square root. So let's go ahead and state our domain and range, and then we'll move on to the next one. So for my domain, I'm going to have x as an element of all real numbers, but x has to be greater than or equal to positive 1 because everything is to the right of 1. And then for my range, y is an element of all real numbers, but everything is above -5, so y is greater than or equal to -5. And there we go. We have our transformations, we have our domain range, and our equation. Okay, let's move on and try out the rational graph. So I have f at x equals 1 over x. Let's start off by graphing our base function. So I know for 1 over x, I have a point at 1, 1, 2, 1/2, and 1/2, 2. And now when you connect the dots, you have to remember that there are asymptotes on your x and y axis, so don't pass the x and y axis. So there's the right side, and then on the left side I'll have the same thing but negative. So -1, -1, -2, -1/2, then -1/2, -2. And again, connect your points and follow the asymptotes. And then I personally like to draw in my asymptotes out as well to give me a nice clear image. So there we go. This is f at x. Now, let's go ahead and write the equation for g of x. I see that for g of x, x plus 3 is horizontal, so that will become my new x. So instead of 1 over x, I'm going to have 1 over x plus 3. And then the plus 6 will just go outside the function. And now, x plus 3 means I am shifting left 3 units. And the plus 6 at the end means I am shifting up 6 units. So this time I am just going to move everything at once. With shifting, I don't really like to do it in 2 steps because then there's too much on the graph, especially for this rational function. But if you prefer going in 2 steps, that is more than fine. So when I shift left and I shift up, it is going to shift my asymptotes as well. So before I even move my actual key points, I'm going to shift my asymptotes because that will give me a nice guide. So I'm going to use green here. For my left movement, that vertical asymptote that's at the y-axis, it's going to get affected because when I move to the left 3, my new asymptote will be at -3. And I'm going to label that x equals -3. And my horizontal one, it's not affected by the right-left movement, but it is affected by the up-down movement. So when I move up 6, my new asymptote will be at +6. And its equation is y equals 6. Now I'll go ahead and shift all of those key points. So I'll start with my 1, 1, and I'm going to move it to the left 3, and then up 6. So here's my new point. And then I'll do the same for the other 2 points. And then I'll connect. And now I'm going to follow these new asymptotes when I connect the dots. And then I'll do the same for that left curve. So the -1, -1 will move left 3 and then up 6 to be here. And then I'll do the same for the others. And then we can connect. And now I can label this as g of x or f at x plus 3 plus 6. Either way is fine. And now let's state the domain and the range. Now for the domain, x can be absolutely anything except for -3 because we have that asymptote there. So that's the only thing we have to state. And same for the range, y can be anything except the asymptote, which is at 6. And there we are. Okay, let's move on to our cos graph. So I'm going to start off by graphing my cos function. And hopefully we remember that cos begins at the maximum of 1. And all of our key points will occur every 90 degrees. So from 1, I'm going to go down to the midline. And then down to the minimum, back to the midline, and then to the maximum. And then I'll label this as f at x. And I'll put arrows at the ends to show that it does continue in this wave motion. And now, our transformed function, g of x, I want you to pause the video here, write the transformed function, write the transformations, and then shift those 5 key points in whatever direction you state. Then come back to the video and check your work. Okay, so your transformed function should be cos x minus 30 degrees plus 2. So you will be shifting right 30 degrees, and you're going to shift up 2 units. So I'm going to do these transformations all in one step. You could have done them in 2. It's up to you. And here I notice that 30 degrees is made up of 2 boxes, and 1 unit vertically is made up of 2 boxes as well. So I'm going to move to the right 30 and then up 2 units, which actually means 4 boxes. So there's the transformed point for that original 0, 1. And then I'll go again. Move 30 to the right and up 2 units. 30 to the right, up 2 units. 30 to the right, up 2 units. 30 to the right, up 2 units. And we connect. I'll label this g of x. And now I know this will go downwards like that. And there's your transformed function. Now we can state our domain and range. The domain is always x is an element of all real numbers. And the range will be based on our new max and mins. So our minimum is now at 1. So y has to be greater than or equal to 1, but less than or equal to 3, which is our new maximum. So that's our new cosine function. And finally, let's try an exponential. Now for this exponential, I have the base as 3. So you might want to draw a little table of values on the side to plot your points, or you can do the table of values in your head. The choice is yours. So if you do a table of values, I would go from -2 to 2, and then just plug that into your calculator. So 3 to the power of -2 would be 1 over 9. 3 to the power of -1 is a third. Anything to the 0 is 1. 3 to the 1 is 3. 3 to the 2 is 9. Now, I personally wouldn't create a table of values. I would just plug these values into my head and then plot them. So let's go ahead and plot everything. But it might be a good visual to have the table of values for when you're shifting things around. And now, just like with the rational, where we had an asymptote, I am going to label my asymptote because the asymptote will shift. So I want you to pause the video here now that we have our base function and finish off this question. State the transformations, write the transformed function, do the transformations on the graph, label it nicely, and then state your domain and range. Okay, so hopefully this is what you have for your transformed function. X plus 3 is up in the exponent, -8 is down below, outside the function, and then you're shifting left 3 units and down 8 units. Now, in terms of your shifting, your horizontal asymptote will not be affected by a right-left movement, but it will be affected by a up-down. So if I'm shifting down 8 units, my asymptote is now going to be at -8. And I like to draw this before I transform my exponential function so that I have a guide for when I connect my dots. And now I'm going to take these key points and I'm going to shift them. Left 3, down 8. And the ones that were really close to the x-axis, you can just estimate them. And there we go. Hopefully you had this for g of x. And for your domain, it should just be x is an element of all real numbers. And your range should just be y is greater than -8, not equal to -8 because we have that asymptote there. So there we go. Those are our shifting transformations. So inside the bracket or inside the function is your right-left movement. Remember to do the opposite sign. And outside the function is your up-down movement.